Welcome to the webinar. You have entered as an organizer and may now speak to any other organizers or panelists on the line. When you are ready to begin the presentation, press the Start Broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast.
Testing 1, 2. Testing 1, 2.
The broadcast is now starting. All attendees are in listen-only mode.
Hello again, Jeff Garbus here for the webinar, What You Don't Know About Your Data Can Hurt You. Thank you for taking a little bit of time and spending it with me today. My background is up here on the screen. I've been working in the IT industry for about, approaching 45 years. I wrote my first computer program at the age of 12, and I've been in databases for over 30 years. I'm not going to spend a lot of time talking about me. I am going to spend just a moment, though, talking about a giveaway. At the end of the presentation, I will talk to you about how to get a free copy of Mining New Gold, Managing Your Business Data. This is our latest book. And I'll be giving away 3 copies at the end of the session. Because they're actual books and not electronic copies, I will be mailing those in the U.S. only. So if you're out of the U.S., my apologies. I'm not trying to give you a hard time, just trying to save a little bit of shipping costs. So that said, this presentation was put together for a CIO type audience. I asked 3 friends of mine who are CIOs that bring me to their company every time they change jobs, and I asked if you were going to be sitting down listening to a database geek, what are those things you'd like to hear me talking about? And every one of them immediately gave me 8 or 10 different things they'd like to hear about, and I took them, combined them, and put them all here. So that said, I'm going to dive right into the types of data issues that CIOs tend to want to hear about. The first one is security. My guess is if you are in the IT industry, you've probably heard more about security in the last couple of years than you care to hear. So I'm not going to focus heavily on this one. I am going to talk a little bit about it, though, because there's some things that you can do to make your own lives easier. We have clients in a variety of different industries. We've got clients in insurance with HIPAA requirements, public companies with Sarbox requirements, credit card processing, SOC compliance, you name it, they're auditing. One of our clients literally has 12 audits a year and have built a number of systems around simply providing information out to the auditors. I would not have the patience to do that. That's one of the reasons I'm a consultant and don't work directly for a very large company, because I like to deal with performance problems and solving issues and not specifically dealing with auditors. That said, the idea of building systems to get them the information they need, if you know they need it a lot, is a good idea, and we have built similar types of things for our customers. The thing that you need to be aware of is that the auditors are going to be coming one way or the other. With any luck, you have a site security officer or some similar job title that is sitting there and has dealt with this type of thing before and are familiar with the regulations that surround your particular industry. Some of the very specific things that you need to deal with is the need to encrypt your data and the need to mask your data. So I'm going to talk about those topics because that's more important than talking about the auditors. That is to say, protecting your data is more important than the specific regulations. As we start talking about encrypting the data, we talk about different states of encryption. The first one is at rest, your storage. So what happens if somebody breaks into your operations center, picks up the disks, and walks away with them? Well, at that point, if you're not encrypted at rest, people are going to be able to simply look through the storage, find your data, and play with it. That's usually a bad thing. So one of the things that we'll talk about is the at-rest encryption. The next is the in-use encryption, which is to say you are looking at the information, and we talk here about several topics, including data masking. For example, we may be able to look at these specific applications and say, okay, this person's allowed to look at social security numbers, this one is not, so when the screen pops up, some people are going to be seeing different things than the other ones. We also get basic access control, which may be role-based, and we also look at topics like authentication versus authorization. So for those of you who aren't into terminology, authentication means are you who you say you are, and authorization says are you allowed to do what you want to do. So when you connect to a server via standard login and password, the login and password provides the authentication. And we'll talk about that again in just a few minutes. And then the authorization is, are you allowed to actually access the data you're trying to get to once you have logged into the server? Finally, we have the in-motion, which is the endpoint control, the secure socket control. And this is not just the stored data, but this becomes a question of, is somebody tapping into your network while you're not looking? And finally, we look at risk assessment. When I talk about risk assessment, I always put my practical joker hat on. If you do not know a practical joker, you need to introduce yourself to one and ask them what they would do to mess things up if they were inclined to do so. That to me is one of the better ways. Once you have your security people lock things down, make sure that they've covered as many of the contingencies as possible. So here we have a quick case study. We do have a client, a healthcare software as a service provider, that was mandated by regulation to encrypt all of their stored data. Well, as you start thinking about how to do that, there are a variety of ways of getting this done. There are a lot of third-party products that encrypt the data on the disk. There are a lot of DBMSs, which allow you to encrypt the data within the DBMS. That's another approach. My personal favorite is simply to let the hardware do it. Storage level encryption enables you to save all the development time. You don't have to worry about integrating another product. You don't need to worry about all the additional CPU cycles of having to encrypt and decrypt the data. If this is all done at the storage level, that saves you any kind of downtime, saves you the encryption time, saves you the CPU, and it is a very low effort approach. So I do recommend that strongly if in fact you have the ability to get there from here. As far as the encryption in motion, this is where you start having your database folks talk to your network folks. So we start talking in terms of, I'm not going to go through every one of these terms, but they're useful as you start talking about how to make the encryption work. So if you don't know anything about encryption, the basic approach is we have a key. The key does the encryption. The key will also do the decryption. You may have different keys for encryption and decryption. There are a lot of ways of working this. I've written a number of white papers on them. But the short version is you need to encrypt it at one end of the pipe and then decrypt it at the other end of the pipe. And the reason is if somebody's got some sort of a sniffer on your network, that keeps them from being able to easily figure out what information is going across the network. This used to be just the type of thing that you'd use if you were working for the government in some sort of top secret affair. Today, this is the type of thing we do for anything which is related to finance, but honestly, almost anything you're doing on the internet now has to do with secure sockets. If you look at the top left of any internet screen, if it says HTTPS, that is a secure internet connection to back out to the web. As you're looking at encryption algorithms down at the bottom, it talks about how many bits you want to encrypt. This is something that's been a matter of argument for a long time. The top secret encryption is 128 bits, and I think that the standard encryption today is 256 bits. So in general, if you go with standard encryption, the chance of anybody being able to figure out what your key is pretty slim. And it's not the first thing that I worry about when I start looking at potential problems. Do note that as you are dealing with the encryption, both in terms of storage and in terms of data, that once you've encrypting, if you're storing encrypted data within your DBMS, you're not likely to get great compression on your backups, because rather than duplicate data, what you're going to have is a lot of hash data. The in-use data protection really is what you're looking at on the screen. This tends to be something which is developed at the application level and handled versus the authentication and the authorization. There are third-party products that you can buy that will sit in between your middle tier and your front end if, in fact, you want to mask data on a role-based basis, but most folks build that directly into their application. That data masking, how are we going to do it? Options, build a middle tier, buy a product that sits in the middle tier, mask it in transit, define it at the database level. Honestly, I like building it into the application and the role-based security into the database, and do not even bring the data back. If you don't bring the data back, you don't have to worry about masking it. I'm a big fan of don't let the problem become a problem. Next, disaster recovery. Disaster recovery today has a very different meaning than disaster recovery had 10 years ago. 10 years ago, disaster recovery usually did not mean the same thing as high availability. Disaster recovery meant, okay, the hurricane hits, what's going to happen? Or the fire hits, or the flood hits, or the earthquake hits, or the mudslide hits. But whatever this natural disaster is, where are we going to go? What happens when the power fails? And we've probably all seen or heard stories dealing with both good and bad approaches. We have one client that has life and death critical operations. They are currently in 3 different states around the U.S., and their auditors came in and asked, what if 2 sites go down rather than 1 site go down? So we've built a solution for them which allows full functionality if 2 of the physical sites go down. So one of the things that you have to ask is, how much are you willing to spend? What is your degree of paranoia? Is your degree of paranoia commensurate with the level of risk? And at that point, as opposed to you, what I tend to do is go to the people with the pockets and ask, well, this is what it's going to cost to give you 1 site failing. This is the cost to give you if 2 sites fail. Is this the amount of money you're willing to spend? And if the answer is yes, we build it. And the answer is not yes, we go back and we price it differently. What I do find is that when you ask folks how much time are you able to be down, their general answer is never, in no time. But then when you start pricing it out, their answers change. So they come back and they say, well, we can only afford to be down. Well, for that cost, what if it's 5 minutes? What if it's 10 minutes? So we start building in plans that bring us to that level. Decide what disasters you're preparing for. Build your DR plan. I talked about enlisting your practical joker. That's kind of important. And the final note is test your DR plan. If your DR plan is not tested, you do not have a DR plan. Note that your DR plans are currently your options are currently changing. In the olden days, we'd have clustering or equivalent. We'd have perhaps, which was some sort of shared storage architecture. That would help in terms of a single machine failing. But then what do you do if the environment fails? You get a power outage, an ice storm. You have your failover now in Atlanta from Tampa, or New York from Atlanta, or Chicago from New Orleans, whatever that happens to be. There are lots of options available today. Most companies have picked one. Not everybody has put it in place, and of that, a small subset have tested these. What I found is, in general, the more serious sites do test these about once a quarter, and that seems reasonable to do your failover testing to make sure that if there is a disaster, we can get there from here. We're in Florida. We have a number of customers that when the last hurricane came by, simply failed over before the hurricane, operated on the reverse site, and failed back after the hurricane passed. This is a great approach, and if you have tested your DR options, this is something that you can do. So take a look at these. Take a look at things like Always On if you're using Microsoft. SQL Server, if you're not using Microsoft SQL Server, look for similar types of features. So the ability to automatically fail over to multiple physical sites, the ability to access the data at the target sites. This, by the way, is a very cool thing. So if your primary site is in Tampa, where I am, and you've got failover sites in New York and Atlanta and Los Angeles, one of the other nice things about having those additional failover sites is that if you set the data to be readable at the target sites, then when people are running reports, people are simply querying data, they've got the ability to pull from the replica. And if you're pulling from the LA when you're in LA, it's going to be a lot faster than trying to pull from the Tampa when you're in LA, because you don't have the response time of the, say, 60 milliseconds it's going to take to get the information back and forth per packet out there from coast to coast. So take a look at the full subset of options that you have available to you. One of the other things that is spoken of a lot is ransomware. You've probably already spoken with somebody who has been a victim of ransomware. This may be an individual who lives in your development, or this may be a company that you've talked to, or somebody that you've heard at a conference. This is currently a really big business, and the ransomware perpetrators are getting smarter and smarter. I spoke with somebody who was a victim of a ransomware attack, and the ransom was $24,999. Now, you can guess what that person's signing capability was. Yes, it was $25,000. So whatever it was that they were perpetrating, they knew enough about the company they were hitting and the people they were trying to hit that they were able to very specifically target something internally and target something where they could get the money back quickly. Now, if this happens to you, this is your decision about what you actually want to do. Are you going to pay it? Are you going to rebuild systems from scratch? Are you going to pick up the downtime? Are you going to call the FBI and have them trace it back, which, by the way, is my preference. I would like to have the bad guys taken care of. So as we're starting to talk about attacks, and ransomware is only one of them, one thing to be aware of is that in the competitions, the hackers almost always win. It is very difficult to take a system and absolutely close the whole system down so that nobody's able to get into it. So what you need to do is build a plan. I mean, your options are pay it, find another company that does decryption. One of the things that the professional security companies have found is that the same key will often decrypt many different places. So if you call for help rather than paying the ransom, it may be that one of the keys that people have collected can decrypt what you've got. What I would tend to do is, if I were stuck there, I would try my failover first and then just simply rebuild the systems from the frame to make sure that nothing there was sitting there. Of course, that is based on my not wanting people to take advantage of me rather than necessarily making a business decision. But that's what your best bet is, to think about what the best business decision for you is and make a decision. So if you are a victim of a ransomware attack, you don't want to have to go to your board of directors and say, oops, because they're going to be really unhappy. What you do want to do is build a plan, document it, bring that to the board and say, okay, we have protected this to the best of our capabilities. It is above industry standards. We think that it is hack-proof. However, should we get that hack? Should we become the victim of ransomware? And there are lots of ways this can happen. Famously, the nuclear site in Iran was hacked by the U.S. team. And how did they do it? They took USB drives and they littered the parking lot with them. And when somebody picked one up off the parking lot, plugged it into their PC, it took their whole system down. So the hackers are very creative. If they do get in, you want to know what your plan is going to be. Lots of potential plans. We strongly recommend you come up with one. Next topic, depth and breadth of experience. One of the things that we get asked frequently is, how do we find sharp people? The ability to find a sharp person is occasionally a challenge. I mean, I've walked into organizations where there are 10 sharp DBAs, and I've walked into organizations where they have a network administrator, 3 junior level DBAs, and they simply can't find a sharp DBA to come in and do work for them. So what happens frequently is we get brought in to do performance and tuning work, and the performance and tuning work identifies a number of areas where our clients are deficient in knowledge. We teach them the things that they weren't aware of, and we walk away, and or we start talking about managed services. But frequently people don't know what they don't know. This case study was a very specific example of people not knowing what they didn't know. We had gone in and done work for this customer. We'd fixed a lot of specific problems. We stopped by for a site visit just to say hi. While there were several of us. The CIO said, hey, Jeff, would you work with the DBA team for a little bit? We had a couple of system down issues over the course of the past few days. The rest of us are going to go tour the data center, see in a few minutes. Well, we immediately identified several issues that needed to be resolved. None of them were things that the current staff were able to look at. So the takeaway here is you don't have to have everybody on staff who knows everything, but you do have to have access to people who understand how to drill down to root cause and identify where things are going on. So we ask a lot of questions. If I'm in an environment like that where we know there aren't any experienced people, what do we need to do to get in there and find out why they don't have that? Ask questions like, is your staff at the technical level they think? How do you find that out? One way is to bring in folks like us and say, hey, how are we doing? Do they have the expertise you need? If you are, for example, looking at a multi-continent always-on implementation, do you have people who've done it before? Can they talk to people who've done it before? Are the people there genuinely interested in learning new things? We'll talk about great interview questions and things to look for in interviews, but frequently when a new CIO comes in, when there is some change in the horizon, people look at protecting their turf rather than learning new things and making things better. One of the things you need to do is make sure you've built a culture where folks are able to ask questions and not afraid to ask questions. But the last question there, do they know they need help, is a very critical one as well. When you identify resources, how do you tech out your staff? One of my favorite interview experiences, I mentioned I've been around for several decades. I was once, and I usually don't get asked for any kind of a tech interview because generally people have either recommended me or they've read my books. But every once in a while they want to go through the tech interview, and I got a call and they said, hey, Jeff, we need you to go out and take this test on the internet before we can put you through the interview process. And I took a look and I called them back and I said, I just want to fully disclose to you that I wrote this test that you're asking me to take. Are you sure you want me to take it? And they said yes. It was a fun experience. But those types of tests, as used for just a first level of screening, are interesting, but you need to make sure that as you're looking at the resources, they know how to address the problems that you've got, or they know how to go find the right answers. That can be really difficult because when you go out on the internet and look for the answers to your questions, they aren't always the right answers, and this can be a big problem. I'm writing an article right now for a group about that specifically and about a subset of information, specifically indexing cluster versus non-clustered, where most of the white papers have it wrong. Breadth of knowledge. Have people worked with the new tools yet, the new versions, the new releases? 2017 SQL Server is coming out. Have people worked with the encryption, with the extended databases, with the you name it? Depth of knowledge. What happens when we start putting 100 terabyte databases out there? Is the DBMS going to handle it? What about the storage? What about the network? What about the volumes of data? What about index rebuilds? What about partitioning? How long is it going to take to do a backup and restore? A lot of these questions need to be asked, and it's very useful to be able to talk to people who've done this before. And finally, beware of your DBA as a single point of failure. We've worked with a lot of companies, large and small. I've worked with public companies that did not have a full-time DBA, and I've worked with small startups that have several. But a frequent situation is that a group will have a single DBA who's working long hours and getting burned out. What do you do when that person actually does quit or needs time off? There was a time I used to ask, what if such and such got hit by a bus? And I stopped doing that because I went into a site, and if a few weeks after I did that, the person was on his motorcycle and got T-boned by a car. He was in the hospital on morphine, working for his employer with broken everything, with his laptop on his hospital bed because there's nobody else there to help out. That is a horrible situation, and if you're in that type of situation, please talk to us about managed services before we're done here. Personality attributes. This was formerly personality attributes of a great DBA, and what I've done is looked in here, and on further reflection, it really works for anybody in IT. There were 3 of us talking, and all of us had 30 plus years of IT experience, and we're just talking about what we look for when we're hiring somebody. And this is the list, the short list that we came up with, of things that we want to see when we're talking to people. Sometimes you can get this with 1 or 2 questions, but if you can't, keep asking questions until you find out how people think about these. All very important. So the first one is that the great IT employee is always learning. There's always more to learn. Anybody who says I'm expert at everything is a very easy no at the interview. Stop the interview right there and move on to the next person. The person who is always on the web, always looking, always reading, always going to conferences, that's the person you want. Next, the great IT employee is meticulous. That does not necessarily mean the person is always combing his or her hair or keeps his or her desk clean, but it does mean that the person has checklists, never misses a trick, everything that needs to be done gets done, and is very, if not punctual, at least very detail-oriented. The great IT employee is proactive, does not wait for things to go wrong, instead looks to see what's going on, watches things in motion, gets ahead of the curve. Constructive paranoia. The great IT employee is an anal retentive compulsive neurotic because they're always asking what can go wrong. What can go wrong with the code? What is a SQL insertion attack going to do? What if somebody actually logs in and guesses a login and password? What if somebody types the wrong thing here? So whatever that happens, make sure that your person is sufficiently paranoid. And paranoia may not be the right word. It may be careful. But you use whatever words you think are appropriate, and make sure that they think that taking backups is important and validating the backups is important. The great IT employee automates everything. Anybody who says, let's just do this manually is not the person for you. That is not a great IT anything. The great IT employee is communicative, communicates early and often. Now, most people in IT have a reputation of not being communicative. We in the IT community have a reputation for sitting in our cubes and doing our thing. Well, there's a place for folks like that. Unfortunately, those are not the ones we tend to get promoted. We as IT people must let management know what we're doing, where we're at, where the project status is, what our blockers are, what we need them to do, and when we expect we're going to be done. We do recommend getting involved online, doing things like lunch and learns, both as attendees and as speakers. Let folks know something that you learned or you picked up. That is a great attribute in somebody in IT who shares their knowledge. And finally, that continual improvement, which is part of the always learning, but always asking the question, how can I do this better? Can I have stopped that problem from happening? Can I make sure it doesn't happen again? Build a process around anything that's going on. All great interview types of questions. Next topic, SAN economics. The place this sort of built was from some personal experiences. Most of what I personally do these days are short-term performance and tuning gigs. Hey, we brought this company in, they couldn't fix it. Somebody said, you can you be here tomorrow? And I've done literally hundreds of these over the course of the last few decades. It's a lot of fun for me. I enjoy it. But every once in a while, you do all the tuning you can, and you get to the point where it's absolutely a hardware bottleneck. Well, when it's a hardware bottleneck, you have to figure out where it is and what the latency is and what you need to fix it. So after going through several of these that were physical storage latency issues, and saying, well, you need faster storage, and they'd always ask, well, what should we buy? I would always say, go to your hardware vendor. That's not us. Well, this was happening often enough, particularly as over the course of the last 5 or 6 years, data needs have increased dramatically. People aren't aging out their data. Data warehousing is collecting lots of information. People aren't deleting things at 3, 7, 11 years. They're keeping it for long-term analysis. So as you're dealing with bigger databases, bigger data sets, larger tables, larger you name it, what ends up happening is you need faster storage and often more memory to bring it up into, because even if you have fast storage, you're still working in memory. So we have found a storage vendor, a flash storage vendor, that sells at dramatically less prices than the rest. It's all enterprise class. We've done this on several occasions, and of the last 3, all 3 customers have bought more storage. So they're seeing it, they're liking it, they're replacing it, and we're getting to the point where the flash storage can be acquired at the same price as the physical spinning disk storage if you're going for high enough volume. So this is something you should be aware of and look at. So the economics have changed. Take a look at it. Note that about 70, and this is a Gartner Group number, by the way, about 75% of customers who buy flash storage don't buy anything else but the flash after they start buying the flash. So keep that on your horizon. Now, if you're looking at flash storage, and note that we are vendor agnostic in this presentation, here are some things that you really need to look for. The first one is adaptive block sizes. Now, to translate adaptive block sizes from technobabble to English, most storage systems, flash storage systems, require you to specify a block size. So let's say, just for the sake of argument, you specify a 2K block size, which is common. Then you go with something like a SQL Server, which requires an 8K page. Well, if you have 2K blocks and an 8K page, that means you've got 4 reads to get the 1 page that you're bringing in. So all of a sudden, your 250 IOP machine has become a 62,500 IOP machine from a database perspective. It's running at a quarter of the speed you think it is because the block sizes don't match up. This is a big problem. I strongly recommend adaptive block sizes. If you can't get them, make sure that the block sizes match your most critical applications, and those are usually databases. The automatic data encryption, let it happen at the storage level. Make sure your performance is consistent and predictable. Some of the flash units, for whatever reason, say we average 3 milliseconds, when what you really want to do is max 3 milliseconds and a median, which is above and below just maybe no more than a millisecond. Make sure you don't need to train a brand new storage team for the new flash storage. You should not need that. Make sure you get great pricing, great warranty, and that your scalability both upward and outward is good. So upward and outward mean you want to be able to say, okay, the 250,000 IOPS don't do it. I need 1 million IOPS. Fine, scale to 1 million IOPS, and then scale outward and say, okay, I need 6 terabytes and not just 1 terabyte, or a petabyte, or whatever it is you're looking for. Next, don't accept yesterday's performance. I've had a couple of quotes in here that I haven't read, but this one just is so near and dear to my heart because people get so used to the way things are. And I've got some favorite stories behind that, which I'm not going to share here, but buy me a beer sometime and I'd be very happy to do that. We got some very specific case studies, and these are very common. I've got dozens of stories like this where simply improving performance has added an enormous amount of money to the bottom line. Take a look at that second bullet item. The first bullet item, $75,000 a month is just a rounding error to very large companies. But even a very large company, if you're taking 3,000 customer service reps and you're shaving a half hour off their time every day all year long, that adds up really, really fast. So make sure that as you're tuning, don't accept, well, this is just the way it's always been. Instead, say, 10 seconds while somebody's on the phone talking to my call center operative is just too long because my call center operatives are saying, well, hang on, our systems are running slower today. And that becomes the impression that people have of my systems, and we don't want that. So if you can't get it fixed, bring in somebody who can identify the bottlenecks, fix the code, fix the database, pick out the individual storage, but don't just accept the performance issues. We have customers who have entire conference rooms dedicated to this type of thing. It's usually called a war room. Everybody goes in there, and the developers point to the database, and the database points to the network, and the network people point to the storage. And generally, whoever has the most people wins because they say it's not us, and there's more of them, so they have more credibility, whether for right or wrong. So I'm a big fan of tools for this. The problem by the numbers is really interesting to me. I'm not going to go through all of these, but some of them are really interesting. The one at the bottom, over 80% of mean time to resolution is spent simply identifying a problem. To me, that's really interesting because tools can often do that immediately. So just investing in a tool to identify performance, very, very important thing just to save a lot of aggravation and a lot of money. So we do recommend picking up a monitoring tool. We do have favorite monitoring tools, and we do caution you that a lot of monitoring tools become shelfware because they look great in the operations center, and the operations folks can point fingers and say, I'm getting lots of information, I'm getting lots of throughput, and everything is up. But that doesn't necessarily give you the information you need when it comes time to drilling down and finding out what your issues are. So for those monitoring tools, make sure it goes if not end to end, at least deep enough drill down so that you can take a look at the data over time, identify patterns, identify outliers, pick up alerting. Make sure you've got not just database information, but operating system level information so that you know if the problem happens to be storage or network and not just in the database. Things not to do. It says don't let your operations team pick the tool. Let's say instead, don't let the operations team pick the tool in isolation. Make sure that everybody who might need to access the tool has some input on whether it does everything it needs to do and not just put out pretty pictures. We had one case study, and this is a personal favorite of mine. We got brought in by a company that does hosting for medical practices. They have, at the time we went in with them, they had several hundred medical practices. They were hosting third-party software, and the response time was in the neighborhood of 20 seconds to 30 seconds to bring up the patient files. And as you know, doctors are known for their patients with P-A-T-I-E-N-T-S, but not for their patients, P-A-T-I-E-N-C-E. So what we did was we went in, we added a lot of indexes, we talked about how to speed things up, and we got things from close to 2 minutes down to the 10 to 12 second range. This was a major improvement, and everybody seemed to be happy when we left that short-term engagement. Well, we got a call back saying, hey, this isn't good enough. We need you to take a look. Well, we had already tuned the application. We tuned the database. We'd indexed things properly. When we did a little bit deeper drill down, we found, well, okay, we've got about 10 to 20% of your time actually doing work. The balance of your time is getting things off the disk and into memory and putting it back. So you need to get faster storage and you need to get more memory. Once they did this, they brought their response time down to 2 to 3 seconds from what was in the 1 to 2 minute range realistically. After performing this, and here's the fun part of the story, the owner of that company went to the third-party medical records company and at a conference asked publicly, well, how much time should it take? And the company said, well, the best we've done is about 10 to 11 seconds. And he said, well, I've got it down to 2 or 3 seconds. He got a lot of attention at that point, and they ended up buying 3 of his competitors, which is a story that I absolutely love. Now, we move into, and this is new terminology, high fidelity databases. The idea behind high fidelity is, do you know that your data is good? And this doesn't have to do with data entry. It does not have to do with data cleansing. It has to do with the actual DBMS itself. Databases can become corrupt. The database corruption is something you need to pick up early on, because if you don't pick up on it early, it tends to snowball. So the first case study, we were brought in, and this one was a potential disaster. This was a medium-sized insurance company, 1,400 employees. We were brought in by a partner who said, Jeff, I don't know if you can do anything about this, but here's the situation. They've just furloughed 1,200 of their 1,400 employees because the Oracle database they had actually wasn't backed up as well as they thought. Their backup solution was hosed. They just spent about $500,000 on it, by the way. And they had the corruption in the data, which went back. This was in November. They called me. The corruption went back through March. So they were really out of luck. We were very fortunate. We were able to identify a group that could go through the Oracle database, corrupt database. And by the way, Oracle had a tool to do that, but the Oracle tool wasn't up for it either. The corruption, once it starts, tends to snowball. And if you think about it, how good is your backup? How recent is your backup? If you have a backup from a week ago and you get corrupt today, do you want to restore from a week ago? That means you get a week of data that's lost, and many companies simply cannot tolerate that. Read a Gartner Group study recently that said 65% of companies with dramatic data loss fail within 30 days of that data loss. The second one wasn't as severe. This is a public firm, had 125 SQL servers, no DBA support. Nobody was looking for the corruptions. After we took this on, we found there were 3 servers with corrupt databases. They had partially retrievable data. The backups were also corrupt. The lessons here are A, look for corruption before aging out your backups, and B, look for the corruption period. Make sure that your data is always good. Master data management, lots of fun as well. And these are not the same CIOs that I spoke of earlier, but of the last 3 CIOs that I've spoken with, All of them were looking at master data management projects near term. For me, near term means they don't have to go out and ask for additional budget for it. SQL Server has a master data services, which does a lot of good stuff. What is master data? The idea behind the master data is that we can model what the data looks like from one organization or one portion of our organization to another. So for example, if I'm in manufacturing, in one system, brown may be BROWN. In another system, it may be BRWN. And yet a third system, it might be the number 12. What master data does for us is give us the ability to find these things, bring them into a common holding area, and potentially push the data back out, but certainly use this for a lot of reporting. By the way, there are third-party applications that do a lot with this type of heterogeneous data gathering and pushing it back out. Note, this tends to be for bringing it all in. If you want two-way replication for this data, then you start talking about expensive processes and enterprise service buses. So, I've been talking for about 45 minutes. If you have any questions, I would be delighted to answer them. One of the things that we talked about at the beginning of this is that I'm going to give some books away, and this is how I'm going to do it. The first 3 people who send me their name and address and say, please send me a book, will get a book. My email address is right here on the screen. Send me hey, Jeff, I'd like one of your books. If you want it autographed, ask for autographs. We'll get everybody who wrote it to autograph it for you. If you don't want it messed up like that, then don't ask for the autograph, because if you don't ask for it, we won't give it to you. That said, I'm going to look over here in the questions tab. If you have any questions, I'd be delighted to answer them for you. Thank you for my time. I tend to rate these webinars and seminars. I did this first at a CIO conference in Charlotte. I tend to rate these by whether people come to me and ask me to or want to talk to me about it afterwards. And we got a couple of clients out of Charlotte, so that tells me that this webinar is at least interesting to some subset of people. If it's interesting to you and you'd like to talk to me about it, shoot me an email or give me a buzz. This is our office number down here. We're located out of the Tampa Bay area, but we've got consultants all over the continental U.S., and we do travel. So thank you for your time. I'm now looking over at questions. And I must be pretty thorough because nobody seems to have any questions, and I'm not seeing anything in the chat window. So I'll leave this open for another minute in case anybody wants to type. But in the meantime, thank you very much for your time. We appreciate your spending your time with us today. Have a fantastic rest of your week and weekend, and hope to meet all of you in person.